In our previous lecture, we have learned about Aldol condensation reactions. It's one of the named reactions in organic chemistry. Today, continuing with the named reactions in organic chemistry, we shall learn about cross-aldol condensation reaction. Before we go into cross-aldol condensation reaction, let us recap about aldol condensation reactions. In aldol condensation reactions, we have learned that two molecules of the same aldehyde or ketones will combine with themselves to form aldol condensation products in presence of dilute alkali and heat. Here, in cross-aldol condensation reactions, two different aldehydes or two different ketones or an aldehyde and a ketone will combine together to form cross-aldol condensation reactions in presence of dilute alkalis like sodium hydroxide or potassium hydroxide and heat to give cross-aldol condensation reactions. The condition is that at least one of the aldehydes or ketones or both should have alpha hydrogen atoms. If both the reacting aldehydes or ketones contain alpha hydrogen atoms, then a mixture of four products is formed. So in cross-aldol condensation reaction, we can expect four products if both the reactants are having alpha hydrogen atoms. Let us see cross-aldol condensation reaction between two different aldehydes. Let's take acetaldehyde and propanaldehyde. Acetaldehyde is an aldehyde and propanaldehyde is another aldehyde. So these two aldehydes are different. They are not the same aldehydes. Okay. Now let us see an easy trick how to write cross-aldol condensation reaction. Let's between acetaldehyde and propanaldehyde. The structure of acetaldehyde is a CH3 C double bond O H. This is the functional group. C double bond O H is the functional group. This carbon atom is alpha carbon. It has three hydrogen atoms. So altogether acetaldehyde has three alpha hydrogen atoms. This is propanaldehyde. CH3 CH2 C double bond O H. This is the functional group CHO. Adjacent to it is the alpha carbon. So alpha carbon has two hydrogen atoms. So this propanaldehyde has two alpha hydrogen atoms. Since acetaldehyde and propanaldehyde both are having alpha hydrogen atoms, when they react, they give four products. So this aldol condensation or cross-aldol condensation reaction occurs in presence of dilute alkali like sodium hydroxide or potassium hydroxide acting as a catalyst. Then a aldol product is formed. This aldol product upon heating will give aldol condensation product. Okay, let us see how it happens. The easiest way to write this aldol formation reaction is, first we are taking acetaldehyde CH3 C double bond O H. This I have written in blue ink so that this will be different from this propanaldehyde. So propanaldehyde I have written in yellow ink. Okay. Now we write the first reactant as it is, CH3 C double bond OH. For the second reactant, which is propanaldehyde here, we expand this alpha hydrogen atoms and write CHH. This is the alpha carbon. These are the alpha hydrogen atoms. Now, in presence of dilute alkali, this hydrogen atom, alpha hydrogen atom, is joined with oxygen atom of the acetaldehyde. That is the first reactant. So, as a result of which we get CH3, CHOH, and a new bond is formed between this carbonyl carbon and alpha carbon of the propanaldehyde. The CH3 present here will be written here, CH3. So as a result of which we get an aldol product, which is 3-hydroxy 2-methyl butanol. The compound formed has 4 carbon atoms. So it is butane. It has an aldehyde group C double bond OH. So it is butanol. It has hydroxyl group on 3rd carbon atom and a methyl group on 2nd carbon atom. So we call it 3-hydroxy 2-methyl butanol. This is the aldol product. Now what happens when this aldol is heated? When it is heated, the alpha hydrogen, one alpha hydrogen has gone here and there is a second alpha hydrogen atom. This second alpha hydrogen I have written upwards. This CH3 I have written downwards. So this alpha hydrogen which was left behind will combine with the OH here and form a water molecule. This water molecule I have written as H2O. Both the hydrogens are from alpha hydrogens of this propanaldehyde and oxygen is from acetaldehyde, first reactant. So when water is removed, this carbon of acetaldehyde and this alpha carbon will join by another bond. So as a result there is a double bond between these two carbon atoms. So this is the CH3 CH double bond C CH3 C double bond OH. This compound so formed has 4 carbon atoms. So it is a but. It has methyl group attached to second carbon atom. So it is, and there is a double bond between second and third carbon. So it is called 2-methyl but 2-enol. Enol because all means aldehyde. So it is a 2-methyl 2-but 2-enol. This is the Aldol condensation product of when acetaldehyde and propanaldehyde are treated with dilute alkali and heated. Let's see what happens when if we take propanaldehyde and acetaldehyde, that is first reactant is taken as propanaldehyde and the second reactant is acetaldehyde. So propanaldehyde, first reactant, remember we write as it is. First reactant is propanaldehyde. It is written as CH3, CH2, C double bond O, H. Second reactant is acetaldehyde. CH3 is written as C, hydrogen, hydrogen, hydrogen. These three hydrogens are alpha hydrogens. C double bond O, H. This is acetaldehyde. Acetaldehyde is written in blue ink. Propanaldehyde in yellow ink for you to differentiate. Okay. Now one of the alpha hydrogens, preferably this hydrogen, alpha hydrogen, is joined to this oxygen atom of the propanaldehyde. We get OH here. So this will be CH3, CH2, CH, OH, and a new bond is formed between carbonyl carbon of the propanaldehyde and alpha carbon of the acetaldehyde. So we get CH2, C double bond O, H. So this compound formed or product formed in presence of dilute alkali acting as a catalyst will have 5 carbon atoms. 1, 2, 3, 4, 5 carbon. So it is a pentane. Okay. There is an aldehyde group present here, CHO. So it is pentanol. There is hydroxyl group on third carbon atom. So it is 3-hydroxy pentanol. This is the aldol product. This aldol product, upon being heated, will give out a molecule of water to form aldol, give us aldol condensation product. Let's see how it happens. This CH3 is written here. This CH2, CH, OH, single bond CH2. These alpha hydrogen, there are 2 alpha hydrogens here. One of the alpha hydrogen will combine with this OH group and will be eliminated as water molecule. Now the water is formed by these 2 alpha hydrogen atoms and oxygen atom of the first reactant, that is propanaldehyde. So we get water is removed. Since water is removed, this bond will shift here and form a double bond between this carbon and the alpha carbon of acetaldehyde. So as a result of which we get CH3, CH2, CH, double bond, CH, C double bond, OH. So this compound or product formed has 5 carbon atoms altogether, and there is a double bond between second and third carbon. So it is called pent-2-enol. Pent-2-enol is the aldol condensation product when propanaldehyde combines with acetaldehyde. Now let's see what happens when propanaldehyde combines with propanaldehyde itself. So propanaldehyde, first reactant propanaldehyde, is written in yellow ink where we have to write it as it is: CH3, CH2, C double bond OH. This is propanaldehyde. Second propanaldehyde, we expand the alpha hydrogens. This is the functional group. This is the alpha carbon. So these are the alpha hydrogen atoms, and there is beta carbon with beta hydrogens. Now we join alpha hydrogen of second reactant with the oxygen of the first reactant, as a result of which this happens in presence of dilute alkali like sodium hydroxide or potassium hydroxide acting as catalyst, as a result of which we get an OH here, and a new bond is formed between this carbonyl carbon and alpha carbon of the second reactant. This beta carbon is written downwards because this carbonyl carbon will form a bond with alpha carbon of the second reactant, as a result of which we get CH3, CH2, CH, OH, single bond, CH, CH3, C double bond OH. So this CHO is aldol functional group. It has, this compound has 5 carbon atoms, so it is pentanol. There is a hydroxyl group on third carbon atom, so, and a methyl group on second carbon atom, so it is called 3-hydroxy 2-methyl pentanol. This is the aldol formation product. Now the condensation product will occur when it is heated. When aldol product is heated, it gives out a water molecule. As already told previously, this alpha hydrogen will combine with OH and form a water molecule. The water molecule is made up of both the alpha hydrogens and oxygen of the first reactant, as a result of which another bond is formed between this carbon atom of the propanaldehyde and alpha carbon of the second propanaldehyde, as a result of which we will get CH3, single bond CH3, CH2, single bond CH, double bond C, and CH3. This is beta carbon. C, single bond C, double bond OH. This is aldehyde function group CHO. So it is a enol. Okay, there are 5 carbon atoms, so it is a pentanol. There is a double bond between second and third carbon, and there is a methyl group present on second carbon, so it is called 2-methyl pent 2-enol. So this is the aldol condensation product when a propanaldehyde is combined with another propanaldehyde in presence of a dilute, alkali and heat. So far we have got 3 products. Let's see the 4th product. Here acetaldehyde combines with another molecule of another acetaldehyde. So first reactant is written as it is CH3 C double bond OH. Second acetaldehyde is written in yellow ink for you to differentiate. So this is the alpha carbon. This is the functional group. This is the alpha carbon. So alpha carbon has 3 alpha hydrogen atoms. One of the alpha hydrogen is joined to this oxygen atom of the first reactant or first acetaldehyde molecule, as a result of which we get CH3 CH OH, and a bond is formed between this carbonyl carbon of the first reactant and alpha carbon of the second reactant. Now one alpha hydrogen was shifted here, so there are 2 more alpha hydrogens here. We write 2 alpha hydrogens here. This is C double bond OH. So it is an aldehyde. It has how many carbon atoms? It has 4 carbon atoms. So it is a butanol because aldehyde functional group is there. So there is hydroxyl group present on third carbon. So it is 3-hydroxy butanol. This is the aldol formation product. This aldol will now, upon heating, give out a molecule of water to form aldol condensation product. Now, how water is formed? When it is heated, aldol is heated, the hydrogen atom, alpha hydrogen atom of this part of the acetaldehyde will combine with the OH group of this part of acetaldehyde. As a result of which we get H2O. See, this H2O is made up of both alpha hydrogens from the second reactant and oxygen atom from the first reactant. So, after losing this OH, this carbon, that is carbonyl carbon, will form another bond with this alpha carbon of the second reactant. So, as a result of which we get CH3, CH double bond, CH, C double bond, OH. It has 4 carbon atoms. So, and an aldehyde group. So, it is butanol. There is a double bond between second and third carbon. So, it is but2-enol. But2-enol is the aldol condensation product of acetaldehyde plus acetaldehyde in presence of dilute, alkali and heat. Now let us see the cross-aldol condensation between an aldehyde and a ketone. Now previously we have seen cross-aldol condensation reaction between two different aldehydes. Now an aldehyde and a ketone. Let's take acetaldehyde and acetone. Acetaldehyde is also called methanol. You must be knowing it. Okay. This is methanol. CH3 C double bond OH. Acetaldehyde or methanol. This is the functional group. CHO is the functional group. Adjacent to it is alpha carbon atom. Alpha carbon has 3 hydrogen atoms. Okay. This is acetone or propanol. Acetone is CH3 C double bond O CH3. This is C double bond O is the functional group. This is the adjacent carbon. This is alpha carbon. This is also adjacent carbon to the functional group. So this is also alpha carbon. So it has 3 alpha hydrogen atoms here, 3 alpha hydrogen atoms here. So since both the reactants have alpha hydrogen atoms, they will give us a mixture of 4 products upon aldol condensation reaction. Let us see the reactions. How to write the reactions in an easy way. So first, let us take acetaldehyde and acetone. Acetaldehyde is the first reactant, acetone is the second reactant. Acetaldehyde, first reactant is written as it is CH3 C double bond OH. Second reactant, this is written in blue ink. Okay. Second reactant is acetone. CH3 C double bond O CH3. CH3 can be written as CHHH. All these 3 hydrogen atoms are alpha hydrogen atoms. One of the alpha hydrogen atom is joined to this oxygen atom of the carbonyl group. As a result of which we will get an OH here. And this carbonyl carbon or carbonyl carbon of the first reactant will form a bond with the alpha carbon of the second reactant, that is propanal, acetone. So as a result of which we get a bond between carbonyl carbon and alpha carbon of the second reactant. So we get CH3, CHOH, CH2, C double bond O, CH3. This is the aldol formation product. This reaction occurs in presence of a dilute alkali like sodium hydroxide or potassium hydroxide. This compound so formed is having 5 carbon atoms. So it is a pentane. Okay. There is a hydroxyl group present on 4th carbon atom. So it is 4-hydroxy pent 2-one because keto group is present on 2nd carbon atom. So it is 4-hydroxy pent 2-one. Instead of none, here we say one. Okay. So it is actually pentanone. Okay. So we write 4-hydroxy pent 2-one. Okay. This compound upon being heated will give out a water molecule and give us aldol condensation product. This alpha hydrogen of the second reactant will combine with the OH group here to form water molecule. This water molecule is made up of 2 alpha hydrogen atoms from this alpha carbon and oxygen atom from carbonyl carbon of the first reactant. So this carbonyl carbon will form another bond with this alpha carbon to form a double bond here. So we get CH3, CH, double bond CH, C double bond O, CH3. There is a ketone group present here. So it is a none. There are 5 carbon atoms. So it is pentanone. Since it has a double bond here between 3rd and 4th carbon, so it is called 3-ene. So the compound's name will be pent 3-ene 2-one because the second carbon is having the functional group of ketone. Okay. So pent 3-ene 2-one is the aldol condensation product formed when acetaldehyde and acetone are treated with dilute alkali in presence of heat. Now what happens if acetone reacts with acetaldehyde? So first reactant is acetone. So the first reactant we know, we write it as it is CH3, C double bond O, CH3. This is the first reactant. Second reactant is acetaldehyde. So this acetaldehyde, instead of being written as CH3, we write it as CHHH. These are 3 alpha hydrogen atoms, C double bond O H. Okay. The second reactant is written in blue ink. First reactant, acetone, is written in yellow ink. Now one of the alpha hydrogen atoms is joined to this oxygen atom of the carbonyl group of the first reactant, as a result of which we get an OH here on this carbon atom, that is carbonyl carbon of the first reactant. Then this CH3 is moved downwards in order to give way for this carbonyl carbon to form a bond with this alpha carbon of the second reactant. So we get CH3, COH, CH3 downwards, CH2, C double bond OH. This is the aldol product when an alkali, dilute alkali is used as a catalyst. So we get an aldol product. It has 4 carbon atoms. The long chain we should count. 1, 2, 3, 4. This downward is the methyl group. It is present on the 3rd carbon atom. So this long chain has 4 carbon atoms. So it is a butanol aldehyde, because this is the CHO, butanol. 3 hydroxy, because hydroxy group is present on 3rd carbon atom, and methyl group is also present on 3rd carbon atom. So it is 3 hydroxy, 3 methyl, butanol. When this aldol product is heated, it gives us a water molecule. The water molecule is formed by the alpha hydrogen of the second reactant and the OH formed on the first reactant. This water molecule contains 2 alpha hydrogen atoms from the second reactant and oxygen from the first reactant. After the water is removed, this OH bond will be transferred to this carbon and this carbon. So there is a double bond between carbonyl carbon and alpha carbon of the second reactant. This is the carbonyl carbon of the first reactant, alpha carbon of the second reactant. So we get CH3, CH3 downwards, and double bond CH, C double bond H. This is aldehyde group CHO. So we get there are 4 carbon atoms, so it is butane. So since there is a methyl group on the 3rd carbon atom, we call it 3-methyl but 2-enol, because there is a double bond between 2nd carbon and 3rd carbon. So this compound is called 3-methyl but 2-enol. This is the Aldol condensation product. When acetone and acetaldehyde are reacted together in presence of dilute alkali like sodium hydroxide, potassium hydroxide, and heated, this is the product we get. This is the Aldol condensation product. Let us see what happens if an acetone, that is a ketone, combines with another ketone. Acetone plus acetone. So first reactant we write as it is. This is written in yellow ink. CH3 C double bond O CH3. Second acetone, we expand the alpha carbons, hydrogens, and write CHHH. 3 alpha hydrogens are written like this. One of the alpha hydrogen is joined to this oxygen of the carbonyl carbon. As a result, we get OH here. And a new bond is formed between carbonyl carbon of the first reactant and alpha carbon of the second reactant. This CH3 group will move this side in order to pave way for this carbon to form a bond with this alpha carbon. So as a result of which we get a 5-membered chain. 1, 2, 3, 4, 5. This carbon is not counted. This is downwards. So the longest chain has 5 carbon atoms. There is a methyl group on the 4th carbon atom, hydroxyl group on fourth carbon atom and a ketone group on the second carbon atom. So it is called 4-hydroxy 4-methyl. Since 5 carbon atoms, it is pent 2-one because keto group is present on second carbon atom. So this is the product we get when acetone reacts with another acetone molecule in presence of dilute alkali acting as a catalyst. This is the aldol product. This aldol product, upon being heated, will give out a water molecule to give us aldol condensation product. Now this alpha hydrogen and OH group will combine to give us water molecule. As you know, this water molecule is made up of 2 alpha hydrogen atoms and oxygen atom from the carbonyl group. So as this bond breaks, this OH bond will have 1 electron. This CH, H will take its 1 electron and go. There is 1 electron left behind. There is 1 electron left behind. These two will form another bond here. So as a result, we get a double bond between this carbon atom, previously carbonyl carbon atom of first reactant and alpha carbon atom of the second reactant. As a result, we get CH3, CH3, double bond CH, C double bond O, CH3. So there are, in the long chain, there are 5 carbon atoms and a methyl group is present on the 4th carbon atom and a double bond is present between 3rd and 4th carbon. So it is called 4-methyl pent 3-ene because double bond between 3rd and 4th carbon. 2-one because ketone group is present on 2nd carbon atom. This is the aldol condensation product. This is aldol formation product when treated with dilute alkali. When the aldol formation product is heated, it gives aldol condensation product. Let us see what happens when acetaldehyde reacts with another acetaldehyde. One acetaldehyde is written in blue ink, CH3COH. So the first reactant always is written as it is. The second reactant, we expand the alpha hydrogens. So CHHH, C double bond O H. This is second acetaldehyde. So this alpha hydrogen is joined to this oxygen atom. This occurs when they are treated with dilute alkali. So as a result, we get CH3, COH and H. This H is already there. This carbon will form a bond with this alpha carbon of the second reactant. As a result of which we get CH3, CHOH, CH2, C double bond O H. This compound is having 4 carbon atoms. So it is a butanol, nol because aldehyde group is present, C double bond OH. There is a hydroxyl group on 3rd carbon atom. So it is called 3-hydroxy butanol. This is the aldol formation product when acetaldehyde plus acetaldehyde combine in presence of dilute alkali. This aldol formation product, upon being heated, gives out a water molecule to give us aldol condensation product. How that happens, we have already seen previously. This alpha hydrogen and will combine with this OH to form water molecule. So as a result of which, this carbon atom and this alpha carbon will form another bond. There is a double bond between this carbon and this carbon. So we get CH3, CH, double bond CH, C double bond OH. This compound is the aldol condensation product. This is having 4 carbon atoms, a double bond between second and third carbon, so it is called but2-enol. This is the aldol condensation product we get when acetaldehyde reacts with itself in presence of dilute, alkali and heat. This is called cross-aldol condensation reaction. Thanks for listening. Please subscribe, share, comment and like. Thank you very much.